So this video we will continue polynomials, the exercise, the last exercise from polynomials, which is 2.2 from the textbook. So here we are doing the problems related to how to find the relationship, how to verify the relationship between the coefficients and zeros of the polynomials. So there are two type of questions. Because it is going to be a very lengthy video, I will do this exercise in two different parts. Let's start. So the first question is to find the zeros of the following quadratic polynomials and to verify the relationship between zeros and coefficients. The first one is x squared minus 2x minus 8. So to find the zeros, we need to factorize this polynomial, and we are using the method splitting the middle term, which we have learned in 8th and 9th. So let's go in very briefly to split the middle term. So here minus 2x can be splitted. So how we will split the middle term? The splitter terms of the middle term, if the product of the splitter terms should be equal to the product of the constant and coefficient of x squared. So if we take the constant and coefficient of x squared, it is 1 and 8. So 1 and minus 8 will give you minus 8. So we need to split the middle term minus 2x in a way that the splitter two terms should be, the product of the splitter two terms should be equal to the product of constant and coefficient of x squared. So which is minus 8. So how all we can write minus? Minus 8 can be expressed as 1 multiplied by 8, 2 multiplied by 4. These are the only two ways how we can when we factorize it, we can express this in 1 multiplied by 8 and 2 multiplied by 4. So if you split the middle term minus 2x, we can split like 2 and 4. So it will be minus 4x plus 2x. So we have splitted minus 2x to minus 4x plus 2x. So after splitting, it will be x squared minus 4x plus 2x minus 8. So we have splitted the middle term minus 2x as minus 4x plus 2x. So see the first part, x squared minus 4x, we have x common here. So taking x out common, x multiplied by x minus 4 plus in the second here we can see which is common here, 2x minus 8, 2 is common. So 2 multiplied by x minus 4. So we have taken x and 2 as common from the first and second part. So x multiplied by x minus 4 and plus 2 multiplied by x plus minus 4. So again we can take x and 2 are common and x minus 4 is common. So x minus 4 into x plus 2. So these are the two factors of this polynomial, x minus 4 and x plus 2. Since x minus 4 and x plus 2 are factors of the polynomial, so we can write x equal to 4. The one of the 0 is x equal to 4 or another one is x equal to minus 2. So the zeros of the polynomials are, how we reach this x minus 4 equal to 0. So x equal to 4. Same way x plus 2 equal to 0. So x equal to minus 2. So 4 and minus 2 are the two zeros of this polynomial. Now let's verify the relationship between the zeros and coefficients. So what is the first relationship? The sum of the zeros is equal to the minus coefficient of x divided by coefficient of x squared. So the sum of zeros, which is 4 plus minus 2, is equal to 2. The sum of zeros is 2, and if you take the coefficient of x, which is minus 2, the coefficient of x is minus 2 and coefficient of x squared is 1. So minus into minus 2 divided by 1 will give you also 2. So minus into minus 2 divided by 1 will also give you 2. So the sum of the zeros is 2 and the coefficient of x divided by coefficient of x squared is also 2. Let's verify the second relationship, which is the product of zeros. The product of zeros, which are the two zeros, 4 and minus 2. So 4 into minus 2 will give you minus 8. 4 into minus 2 will give you minus 8, and it is equal to the constant term divided by coefficient of x squared. So the constant term is 8 here, minus 8. We need to take minus 8. So with the sign, so minus 8 divided by coefficient of x squared, which is 1. So minus 8 divided by 1 will also give you minus 8. So we have proved that the product of zeros are equal to constant term divided by coefficient of x squared. Let's move to second question. 4s squared minus 4s plus 1. So here same, we need to factorize this polynomial using splitting the middle term. So 4s minus 4s can be splitted as minus 2s and minus 2. So 4s squared minus 2s plus 1. So we have splitted this middle term to minus 2s minus 2s. So taking 2s as common here. So if we see 4s squared minus 2s, we can take 2s as common. So 2s into 2s minus 1 minus here which one is common in the second part 2s plus 1, we have only 1 common. So 1 into 2s minus 1, which will give you 2s minus 1 multiplied by 2s minus 1. So the zeros of this polynomial 4s squared minus 4s plus 1 are 1 by 2 and 1 by 2. How? If 2s minus 1 equal to 0, then 2s equal to 1, s equal to 1 by 2. So we have 1 by 2 and 1 by 2 are the two zeros of this polynomial. Let's find the verify the relationship. The sum of the zeros 1 by 2 plus 1 by 2, taking the LCM we will get 1 by 4. 1 by 2 plus 1 by 2 will give you 1, and the coefficient of s divided by coefficient of s squared. So minus coefficient of s is, the coefficient of s is minus 4. So minus into minus 4 divided by coefficient of s squared is 4, which is also equal to 1. So the sum of zeros is equal to 1, and the minus coefficient of s divided by coefficient of s squared is equal to 1. So we verified the first relationship. The second one is product of zeros, which is 1 by 2 multiplied by 1 by 2 will give you 1 by 4. And the constant term here, which is a constant term, we have 1, and the coefficient of s squared is 4, which is also equal to 1 by 4. So we have verified the second relationship also, like which is the product of the zeros are equal to constant term divided by coefficient of s squared. The third one is, the third question is 6x squared minus 3 minus 7x. So we again we need to rewrite this polynomial in the format of ax squared plus bx plus c. So here 6x squared minus 3 minus 7x. So this is rewritten as 6x squared minus 7x plus minus 3. So we have bring the 7x to in front of the constant term. So 6x squared minus 7x minus 3. Again we are splitting the middle term by using the splitting the middle term method. So taking 6, the product of the constant and coefficient of x squared is 6 multiplied by 3 is equal to 18. 18 can be written as another way 2 multiplied by 9. So we can make 7x by using this 2 and 9. So it can be, we have splitted the middle term to 6x squared minus 9x plus 2x. So we have splitted 7x to minus 9x plus 2x. So after splitting, the polynomial is 6x squared minus 9x plus 2x minus 3. We have splitted the minus 7x as minus 9x plus 2x. So for taking the first part 6x squared minus 9x, for which is common, we have 3 and x. So we taking 3x common outside, 3x. After, if we take 3x from 6x squared, what is left over? We have only 2x. So to 3x multiplied by 2x minus, and here if we take 3x from 9x, we have only left 3 here. So 3x multiplied by 2x minus 3 plus, in 2x minus 3 there is nothing common, so we can take 1 multiplied by 2x minus 3. So which is 3x plus 1 multiplied by 2x minus 3. So the zeros of the polynomial 6x squared minus 3 minus 7x are minus 1 by 3 and 3 by 2. So how 3x, if 3x plus 1 is one of the zeros, so 3x plus 1 is equal to 0. So 3x equal to minus 1, x equal to minus 1 by 3. So how we will find it? X equal to 3x plus 1 equal to 0. So 3x equal to minus 1, then x equal to minus 1 by 3. And similarly for the second one, 2x minus 3 equal to 0. So 2x equal to 3, x equal to 3 by 2. So the first 0 is minus 1 by 3 and the second 0 is 3 by 2. So let's verify the relationship. The sum of zeros, which is minus 1 by 3 plus 3 by 2, will give you 7 by 6. Taking the LCM, we will get minus 1 by 3 plus 3 by 2 is 7 by 6, and the coefficient of x divided by coefficient of x squared. So which is the coefficient of x? Coefficient of x is minus 3. We need to take minus coefficient of x. So that is minus into minus 3, minus 7, sorry, minus into minus 7 divided by coefficient of x squared is 6. So minus 7 into minus 7 by 6 will give you 7 by 6, which is equal to the sum of the zeros, 7 by 6. Next one is product of zeros, which is minus 1 by 3 multiplied by 3 by 2 is equal to minus 3 by 6, which is equal to the constant term. The constant term is minus 3 and the coefficient of x squared is 6, minus 3 by 6. So we verified the second relationship also. Let's move to the next question, which is the next question is 4u squared plus 8u. So 4u squared plus 8u, there is no constant term. We can assume it as 4u squared plus 8u plus 0. So now we in 4u squared plus 8u, which is common here, we have 4u as common. So taking 4u as outside, what is left over here? We have u, and here if you take 4u from 8u, we have left 2. So 4u multiplied by u plus 2. So if we can say 4u, and so u plus 2 is the factor of this polynomial. So if u plus 2 is equal to 0, then u is equal to minus 2. So we have u is equal to minus 2. So one of the 0 is minus 2 and other one is 0. So the two zeros of this polynomial is 4u squared plus 8u are 0 and minus 2. So let's verify the sum of zeros, which is 0 plus minus 2 is equal to minus 2 and equal to coefficient of u divided by coefficient of u squared. The coefficient minus coefficient of u. Minus coefficient of u, it is here minus 8 divided by coefficient of u squared will give you 4, and minus 8 divided by 4 is equal to minus 2. So we have verified that sum of zeros are equal to the coefficient of u divided by coefficient of u squared. The second relationship, product of zeros, which is 0 multiplied by minus 2 is equal to 0. The same way, the constant is equal to constant term divided by coefficient of u squared. The constant term here is, we don't have the constant term, so assuming it as 0, 0 divided by coefficient of u squared, which is 4, 0 divided by 4 will also give you 0. So this is also verified, the product of zeros are equal to the constant term divided by coefficient of u squared. So let's move to the last question, which is equal to, we can write it as t squared is equal to 15. So t is equal to square root of plus or minus 15. So zeros of this polynomial are, we can write it as square root of 15 or minus square root of 15. So sum of the zeros, minus square root of 15 plus minus square root of 15, which is equal to 0, is equal to coefficient of t divided by coefficient of t squared. So since we don't have t here, what we have to say, we can write it as, in a polynomial, if the second variable is not the t squared minus 15, we can write it as t squared plus 0t minus 15, which is 0t. So here if it is 0t, the value of the second term is 0. So value of the second term is 0. So we can, the coefficient of t is here minus 0. So if to verify the sum of zeros, we have to take the coefficient of t. So coefficient of t is here minus 0 divided by coefficient of t squared is 1. So it's minus 0 divided by 1 is equal to the sum of zeros, minus 0 divided by 1. So that's how we need to rewrite. If there is the second term is not given, so we can assume it as 0t, which is equal to 0. And the product of zeros, which is square root of 15 multiplied by square root of 15, will give you minus 15. And the constant term here, it is minus 15 divided by coefficient of t squared, we have 1. So minus 15 divided by 1. So this is also equal to the product of zeros. I hope this is clear. So this is a little bit confusing. The first one, they have given only t squared minus 15. So we need to assume the second term as 0t, which is the value of 0. The last question is 3x squared minus x minus 4. So similarly, we have 3x squared minus x can be splitted as minus 4x plus 3x. So we have splitted minus x as minus 4x plus 3x. And in the first part, we have what is common here in 3x squared minus 4x, we have x common here, and after taking x from 3x squared, we have what is left over, we have 3x here. Then from 4x, if we take x, we have only minus 4. So 3x x multiplied by 3x minus 4 plus, in the second part 3x minus 4 we can take, there is nothing common, so 1 is the common, so 1 multiplied by 3x minus 4. Again 3x minus 4 we have common here, 3x minus 4 multiplied by x plus 1. So 3x minus 4 and x plus 1 are the two factors. So the zeros of this polynomial are, we can write 3x minus 4 equal to 0. So 3x equal to 4 and x equal to 4 divided by 3. So the one of the zeros is 4 by 3, and the second 0 x plus 1. If x plus 1 is a 0, then x equal to minus 1. So value of x is minus 1. So two zeros are 4 by 3 and minus 1. Let's verify. Sum of zeros equal to 4 by 3 plus minus 1, which is equal to 1 by 3. 4 by 3 plus minus 1 is equal to 1 by 3. And which we needs to verify the coefficient of x. The coefficient of x is minus coefficient of x is minus into minus 1 divided by coefficient of x squared is 3, so which is 1 by 3. Okay. Minus 1 by 1 minus 1 by 3 and is equal to sum of the zeros, minus 1 by 3. And the product of zeros, the two zeros are 4 by 3 multiplied by 1, which is equal to minus 4 by 3. 4 by 3 multiplied by minus 1 is equal to minus 4 by 3 is equal to constant term. The constant term here is minus 4 and coefficient of x squared is 3, which is also equal to minus 4 by 3 and minus 4 by 3. So now we have verified the sum of zeros and are equal to coefficient of x divided by coefficient of x squared, and product of zeros are equal to constant term divided by coefficient of x squared. So students, we will do the second part from this exercise in the next video because it's going to be very lengthy. Let me know your comments, and if you are new to the channel, please subscribe. Thank you for watching.